Therefore, it will be minus sin 30. Therefore, sin and one thing that part of the revolving ray which is considered as hypotenuse will be. Now the final thing is that how to find the trigonometrical ratio of any. First of all, we have to express the given angle in terms of the multiple of 90 degree or multiple of 180 degree, then plus or minus the certain angle. Let us take an example. To find the trigonometrical ratio of the angle 220, what to do? First of all, we see this 210 degree can be written as (210 degree is equal to 2 times 90 degree plus 30 degree. Now I want the trigonometrical ratio of sine trigonometrical ratio of 210 degree. That means now if you find that 90 degree occurs in even form, then the trigonometrical ratio will be unchanged. That means this will be sine 30 degree. Only we have to determine the sign. What will be the sign here, positive or negative? For that, we have to find the terminal position of the revolving ray. For that, you draw a diagram like this. Then you see twice 90 degree. That means the revolving ray crosses OX dash and comes to this position. Like consider this. That means the terminal position of the revolving ray in the third quadrant where sign is negative. Therefore, it will be minus sin 30. Therefore, sin 210 degree equal to minus sin 30 degree. Now, that is equal to minus half. Thus, first thing, you express the given angle as a multiple of 90 degree or 180 degree, then plus or minus specific angle. Accordingly, if you express that angle as even multiple of 90 degree, then trigonometrical ratio will be unchanged. For determination of the sign, you mentally find where the final position of the revolving ray, and accordingly you put the sign plus or minus. In case of plus, we don't mention that. Thus, we have learned how to find the trigonometrical ratios of any angle. Considering the negative angle also, we can find it. For that, we take another angle. Say minus 300 degree. And we want to find the tan ratio. Now already you have learned that tan of minus theta will be equal to minus tan theta, tan 300 degree. Now let us break 300 degree like this. 360 degree minus 60 degree. That is 4 into 90 degree minus 60. Therefore, minus 10, 4 into 90 degree minus 60 degree. Minus tan 60 degree. Now, the sign issue. What will be the final position of 300 degree angle? That means if the revolving ray rotates in full, it will cover 360 degree, then it comes back to 60 degree. That means final position is within the fourth quadrant, where tan ratio is negative. Therefore, it will be minus tan 60 degree. Thus, we get finally tan 60 degree. Therefore, tan of minus 300 degree is equal to tan 60 degree, and already you know that tan 60 degree equal to. Thus, we have found trigonometrical ratios of any angle of any amount, because if the angle is greater, then that can be expressed as multiple of 90 degree or multiple of 180 degree, etc. This is the matter of the chapter trigonometrical ratios of any angle, that is trigonometrical ratios of associated or allied angles. And the other thing you have learned in class 10, the trigonometrical ratios of some specific angles. Already I have made a chart, trigonometrical ratios for the angles 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. For sine ratio, the values will be respectively 0, half, 1 by root 2, root 3 by 2, 1. Values of cosine theta will be just reverse of the values stated for sine. That is, for 0 degree, cos 0 degree will be 1, cos 30 degree will be root 3 by 2, cos 45 degree will be 1 by root 2, cos 60 degree will be half, and cos 90 degree will be 0. And tan ratios already you see from the table are 0, 1 by root 3, 1, root 3 and undefined. Why undefined? Because tan 90 degree, that is equal to sin 90 degree by cos 90 degree, and cos 90 degree is equal to 0. Therefore, division by 0 already you have learned in lower classes that is undefined. Thus, up to this we have learned in class 10. Now we are moving to class 11. As we have mentioned that angles in trigonometry will be of any amount of positive as well as negative. Therefore, we are to find the trigonometrical ratios of any angles, that is discussed in the chapter trigonometrical ratios of associated angles or allied angles. First, we find the trigonometrical ratios of negative angles. In class 10, we have found trigonometrical ratios of acute angles as well as 0 degree and 90 degree angles. We have not learned how to find the trigonometrical ratios of negative angles. Now we are going to find the trigonometrical ratios of negative angles. For that, I draw a diagram. From the initial position OX revolving in the anticlockwise direction, it comes to the position OX1, so that XOX1 equal to theta. That will be positive as it is revolved in the anticlockwise direction. Now rotating in the clockwise direction, it comes to the position OX2, so that XOX2 equal to angle theta. As it is revolving in the clockwise direction, therefore the angle will be of measurement minus theta. Now we take a point P on OX1, draw perpendicular on OX, then we extend that to intersect OX2 at the point P1. Now we can show easily the congruency of the two triangles formed ONP and ONP1, so that lengths of NP and NP1 will be equal, and lengths of OP, OP1, those are also equal. And one thing, that part of the revolving ray which is considered as hypotenuse will be always positive, whether it is lying in any of the four quadrants. For that, OP1 will be equal to OP, O, NP1, that will be NP1. You see, the point P1 is lying in the fourth quadrant. According to the sign convention, NP1 will be equal to minus NP. Now let us find the trigonometrical ratios of the angle minus theta. One thing, initially we take theta lies in between 0 degree and 90 degree. Now let us find the trigonometrical ratios of minus theta angle. Sine of minus theta, as per the definition you have learned, perpendicular by hypotenuse. From the diagram it will be NP1 by OP1, and already I have mentioned that NP1 is equal to minus NP by OP. Now already we have found that sine of minus theta, consider this triangle, sine of theta, that will be equal to NP by OP, therefore it is nothing but minus sine theta. Thus sine of minus theta will be equal to minus sine theta. Next, cosec minus theta we can prove geometrically, or we can use that cosec of minus theta, that is equal to 1 by sine of minus theta, and after calculation it will be minus cosec theta. Next, cosine of minus theta, that will be equal to, from the diagram you see, base by hypotenuse, that means ON by OP1, and ON by OP1 already we have shown, and this is equal to what? Cos theta. Therefore cos of minus theta is equal to cosine theta. Similarly, we can show tan of minus theta, that will be equal to minus tan theta. Cot of minus theta, that will be minus. Thus, we have learned how to find the trigonometrical ratios of negative angles. One thing you remember or you keep in your mind that initially we take theta, measurement of theta, that is in between 0 degree and 90 degree.